ground shit.
In solution to this problem, we have made a circuit which indicates the sound level through LEDs. Myself, Soham Kedari.
Myself, Yuvraj Munge, and we are the students of SPIT. We made this project under the guidance of Sneha Weakey ma'am and co-guidance of Najib Ghatte sir. So this circuit is used to demonstrate detect the sound of surrounding sound and visualize the sound using LEDs. So hello. As we discussed the problem of high sound level indicator, we made a circuit using an op-amp. To make an sound level indicator, we thought of using an op-amp as a comparator. So we just made a small circuit to demonstrate how it works. So as shown in the simulation, we made this circuit. There are four power supplies: VCC, VE to turning on the op-amp, input voltage and reference voltage. Look for making a small comparator. We require four power supplies for an IC741. So the working is like that: if the input voltage is greater than reference voltage, we will get an output. If reference voltage is greater than input voltage, we will not get an output. Like if sound level is less than our input voltage, we will get an output. So it's simple working. So let's see. If look, here is an input voltage 5 volt and reference voltage is 3 volts. We are getting an output. And if I change a reference voltage to 6 volt, we will not get an output. Look here, we are not getting an LED turning on. So it's simple a comparator circuit which will compare two input signals and it gives an output. So when we thought of making and this circuit, we required a 10 output LEDs, but it is not comparable to use an IC741 to make this circuit. So we shifted on LM339, which is an 4 comparator based ICs. In this IC there are 4 comparator op-amp comparators. So we are using LM339. So to use this IC, we made this circuit how it will work. So there are these registers, this 1K register, which will act as a potential difference. Look here, these two registers will make a different potential, and it is given to an comparator input as a reference. These two will make a different and given to a comparator. These two will make a difference. Like these 5 register will make different reference voltages to give as an reference input to 4 different comparators, and input is changed using this variable resistance. So to demonstrate how the sound will work, if sound level goes from 1 2 3 4 5, our LED will turn on. So in this circuit we made a in this circuit we show that if voltage level will go 2 4 6 8, for 2 4 6, for 2 this LED work, for 4 this will turn on, for 6 this will turn on, for 8 this will turn on. And look, here we have required 4 different power supplies, but here we only required a 9 volt battery, and this is really practical. So let's see, if I change a potentiometer, like 2 volt we get a LED, for 4 volt we get an LED, for 6 volt we get an LED, for 8 volt we get an LED. So this is working. But now we have to make a 10 op-amp 10 comparator based circuit, which is not possible on this software. So we are using an Proteus to finally making a proper working circuit. So let's go. So we made a working 7 comparator circuit using an 2339 ICs in Proteus. And here is we have used an op-amp to amplify the input audio signal. This op-amp will work as an audio amplifier to amplify the audio signal. There is no audio input in the proper output audio input available in Proteus. So we made a pulse generating circuit which will generate a pulse as an audio signal, audio input, and we will demonstrate working how it will work. So we have added some different components, like we have added a relay system, we have added a temperature indicator system and LDR light indicator system. When we have thought of why to limit the circuit only for sound indication, we can also use it for a temperature indication, light intensity indication, and any other analog input indication like alcohol standard indication, anything, any we can make it. So we have given this circuit a name as ultimate indicator, which can indicate any analog input signal. So when this audio signal is given to an op amp, this op amp will amplify the signal, and this signal is given to all the reference uh, comparator, and there is an a register in connected in series, which will act as a voltage divider, and it can make a different make a different positive references voltages. So we will compare it. So let's see how it's work. So look, it working very fine. Like, look, this signal is given, and we are getting an output here, and this relay is used when a sound level is go for some, like sound level will go about 200 dB. It will indicate that the sound is too high, so the system will turn the input off. This relay will turn off, and relay will turn on when the input is lower than 200 dB. So this is our sound level indication circuit we made. This transistor are used, will turn on, and the relay will also turn on, and this circuit is used for identifying the signal is less than 200 dB or any other sound level indicate level. And when the sound level will goes down of 200 dB, this circuit will make relay to turn off. And look here, then we have added various different switch to convert to switch the circuits. Now we have temperature based circuit. This temperature circuit, if the temperature will is go on something more like 50 degrees Celsius, 40 degrees Celsius, 45 degrees Celsius, it will indicate, like for 20 degrees Celsius this LED will turn on, for 25 this, for 30, for 40, 45, 50, 60, and after 60 degrees Celsius fan will turn on our fan will turn on to cool the system down. So this was the concept behind and temperature indication circuit. So let's see how it's work. So let's see here. So as uh, temperature is high. Wait, look here. So when I will increase the temperature, look, the last LED is also turned on, and our fan is also turned on. This was the concept behind this. If I reduce the temperature, look, if I reduce the temperature, our LEDs will turn off one by one. Our LEDs are turning off one by one. Look, for 17, for 13, look, these LEDs are turning off one by one, and our motor is also turned off. And this was the main concept behind this circuit. And same goes to the LDR circuit. The light intensity will showcase on our output, and we will get for different light source we will get an output. So we can add more input circuits to this, so we can indicate anything.
So now let's get into the hardware implementation part.
In this circuit, we have used IC LM3915, which is a LED indication IC which consists of 10 comparators. Before, we have seen why the space management is required in advanced mixed signal ICs. This solves that problem as this IC consists of 10 comparator circuit with a 10-step voltage divider circuit, which makes different reference voltage for different comparator in the IC. Here we have placed 4 green LEDs, 4 yellow LEDs, and 2 red LEDs to indicate the level of the sound. And now let's demonstrate the circuit. We have given input through the laptop by the audio jack and a 12-volt power supply. Now let's give the input and observe the output on the LEDs. As you can see, as we give the input, the LEDs start glowing as per the input sound. If the input is very high, then the red LED glows, and if the input voltage or the input sound is in low range, the green and yellow LEDs glow. That indicates that it is a safe sound.